Hello everyone, this video is about geometric progression. Let me begin with an example. Consider this sequence 1, 1 by 2, 1 by 4, 1 by 8, 1 by 16, so on and so forth. Here you can see that we are multiplying each term by half to go to the next term. So I can also write this as 1 comma 1 by 2. This is just 1 by 2 square, 1 by 2 cube, 1 by 2 raised to 4, so on and so forth, and the nth term will be 1 by 2 power n minus 1. Because to get the second term, we are multiplying the first term by half once, for the third one twice, the fourth one 3 times, so the nth term will have to multiply by n minus 1 times. So this kind of sequence where we start with a first term, let's call it A, and there is a constant multiplicative factor, or I would call it ratio between the two terms, any two consecutive terms, as R, and we go from A to other terms by multiplying R each time. This kind of sequence is known as geometric progression. So here in this example, the first term is just 1, and the ratio between any two consecutive terms is half. So it is same as when you divide second term by first, or let's say fifth term by the fourth term. So we multiply 1 by 2 to get the next term. So I'll write this in general. We have A, AR, AR square, AR cube, so on and so forth. We multiply by R each time to get the next term. Now the nth term in this sequence will be A times R power n minus 1. Again, with the same logic that I used here to justify that the nth term will be 2 power n minus 1. It is the same logic here, that to get the second term we multiply R once. For third term we multiply twice. So for nth term we multiply R n minus 1 times. So it will be R power n minus 1 factor here, multiplying the first term. So let me write this. Nth term will be A times R power n minus 1. This is the formula we can use to calculate the nth term in the geometric progression. Now I'll consider another example. I have, let me start with 3, and let the multiplicative factor be 2. So 3 into 2 6, 6 into 2 12, 12 into 2 24, into 2 48, and so forth. So in this geometric progression, if I want to calculate, let's say, the 9th term, A9, then I can use this formula, and I have A times, so here A is 3, so 3 times R power n minus 1. Here R is 2, so let me write that explicitly. A is 3 and R is 2 here, the constant multiplicative factor between any two consecutive terms. So 3 into 2 power n minus 1, so that will be 9 minus 1. So this is 3 into 2 to the power 8. Now what is 2 to the power 8? So let me do that quickly. So basically we have 2 8 times, right? 2, 2, 2, 2. So 4 8 16 32 64 128, and 128 into 2 will be what? 8 16 256. So this is nothing but 3 into 256. Now let's do this multiplication. 6 3s are 18. We have 1, then 15, 16, 1 and 7. Okay, let me check this with my calculator whether so 3 into 256. Yes, I did the calculation correctly. So the a ninth term will be this for the geometric progression that I have considered here. Now there is another formula similar to the arithmetic progression where we found sum of first n terms. Here also we can find sum of first n terms of a geometric progression, and the formula for this is Sn is equal to a times 1 minus r power n upon 1 minus r. So this is nothing but sum of first n terms of geometric progression. Now you can use this to calculate the sums, but first let me justify or actually prove it to you how this formula occurs. So when I have the geometric progression as ar square, ar cube and n terms, so a into r power n minus 1, and when I take Sn, I am just adding all these terms, so a plus ar plus ar square till the last term, the nth term, a r power n minus 1. So this is our Sn. Now what I'll do, I'll multiply this equation, let me call it star. I'll multiply this star by r, the constant ratio. So what I will get is the left hand side will just be r times Sn, and we have ar multiplying r to all these terms individually. So this will be ar, this will be ar square, this will be ar cube, and we will go till the last term. The second last term will be a into r power n minus 1, and the last one will be a times r power n. So when we multiply this by r, we get the last term, and this is the second last term because here it will be a times r power n minus 2, right? So multiplying that by r will give us the second last term, this. So let me clean this up a bit. So we have these two equations, Sn and r times Sn. Now what I'll do, I'll subtract this from this. So let me write that down, Sn minus r times Sn. This will give us, and now I have to subtract this, so it's basically this whole thing minus this whole thing. Now let me subtract this term from this term, so Sn minus r times Sn, and you'll be able to see that all these terms of the second terms, if we subtract them from this sum, this all will cancel because they are common, so they will all cancel here till a times r power n minus 1. The only terms remaining will be a minus a times r power n, because the rest of the terms are cancelling when we subtract this term. Sorry, let me be clear about it. So when we subtract this term from this Sn, so this is our equation. I'll take Sn common here, so I have Sn times 1 minus r, and on the right hand side I'll take a common, so a times 1 minus r power n. So Sn will be equal to a times 1 minus r power n divided by 1 minus r. Now just to illustrate the this like use of this formula with an example, let me consider a geometric progression. I'll take 1 and let me have the multiplicative factor as 2 for the ease. So 2 into 2 4, 4 into 2 8, and so forth. So let's say I have this sequence and I want to find sum of first 5 terms. So S5, which is nothing but 1 plus 2 plus 4 plus 8 plus 16. Let's say I have to find this. So from this formula here, I can calculate this by taking A into 1 minus 2 power 5 divided by 1 minus R. So 1 minus 2. Okay. Because here this is our A and 2 is our R, constant ratio. So this will just be 1 minus, and 2 power 5 will be 16 and divided by minus 1. So this is minus 15 by minus 1. So just this is only 16. This will be 32, not 16. Yeah. So let me check this. Yes, I have 4 times. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. So yeah, if we have 2 power 5, it's 32. So I have this. Then this will be equal to minus 31 upon minus 1, and which is just 31. So the sum of first 5 terms of this geometric progression, this one here, is 31. Now let's check this from actually adding up all these terms here. So okay, I'll just write it alongside this. So here 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 8 is 15, and 15 plus 16 will be 31. So this formula is indeed giving us the expected result, and you can check this derivation again more carefully to derive this formula. Now there is one special case of this SN formula, that is when the magnitude of R, when R is less than 1, and as let's say n tends to infinity, so we're adding infinite number of terms, then Sn will be A times 1 minus R power n upon 1 minus R, and this factor here, since R is less than 1, then R power n will go to 0 as n tends to infinity, because R is like a fraction, and a fraction raised to a very large power will tend to 0. So this will go to 0. So I'll write S as, okay, let me be explicit here. So R is less than 1 and n tends to infinity, then the sum will be A times 1 minus 0, because this goes to 0 as n tends to infinity, upon 1 minus R. So this is nothing but A by 1 minus R. So this is sum of infinite number of terms of a geometric progression who have this ratio less than 1. So let me see one example here again. So let's have now a negative constant ratio. Let's say R is minus half and A is, let's say, 2. So the sequence will look like first term 2, 2 into minus half, that is minus 1, into minus half will be 1 by 2, into minus half will be minus 1 by 4, and so forth. So here if we add all these up infinite number of terms, and this goes on till infinity. Then this s from this formula should be a, which is 2 upon 1 minus r, and r here is minus half, so I'll have to write minus half here. Minus half. So this will be 2 upon 1 plus 1 by 2. So this is nothing but 2 into 2 upon 2 plus 1 by 2. So this is 4. This goes up, becomes 4, and this is 4 by 3. So here sum of these infinite number of terms actually converges to 4 by 3. So this was all about the geometric progression, and for your reference I'll write all the formulas again. So geometric progression is when you multiply a first term by a constant factor r. So ar square, ar cube, and so forth. And the nth term will be a times r power n minus 1, as we saw before. And the sum of first n terms of this geometric series, geometric progression, will be a into 1 minus r power n upon 1 minus r. So these are like the main formulas, and you can solve more examples on this to practice it and to understand it better. Thank you.